Reactions due to temperature. Good morning, good afternoon, and good evening, everyone. Today, we're going to explore the fascinating world of temperature-induced reactions. But before we get started, take a moment to check out this intriguing phase diagram. A phase diagram is like a map that shows us how different substances behave under different temperatures and pressures. It's like a sneak peek into the secret lives of solid, liquids, and gases. This visual tool helps us predict how a substance will change from one phase to another based on its surroundings. Today's topic will focus on the freezing and boiling point of a pure solvent and how do they compare of those of a solution. Boiling. Boiling is a natural process in which a substance changes from a liquid to a gas, as the vapor pressure of the liquid equals the external pressure acting on it. This process is unique to each substance and can be influenced by various factors. Now, let's join Ms. Laguitan to explore her discoveries about boiling water.
Meron akong dalawang container na naglalaman ng 1.5 cup of water each. Naglagay din ako ng salt sa isang container. At titignan natin kung saan ang pinakamataas ang temperature once na nag-start yung 5 minutes na oras natin. Makikita nyo dito, mas nauunang bumubula yung container na ito, unlike dito sa kabilang to. Hintayin natin hanggang sa mag-dissolve yung salt. Ngayon, nakikita natin na mas nauunang mag-boil yung may salt na container, unlike yung walang salt. Yan talagang nagagawa ng salt when you boil water. Siya yung nagpapadali ng pagtaas ng temperature at siya rin yung nagpapadaling mag-boil ng water.
Thank you, Ms. Laguitan. Let us interpret the situation here. What's happening is that the vapor pressure of the solution is lower than the vapor pressure of the solvent. This means that more energy is needed to convert the solution from liquid to gas, causing its boiling point to increase. This phenomenon occurs in solutions where the presence of solid particles disrupt the formation of the solvent vapor, requiring a higher temperature for the solution to boil. But if we think about it, wouldn't the solution take longer to boil since it has a higher boiling point? According to termtest.com, when adding salt into a pot of water, it will make it more challenging for water molecules to escape the pot and enter the gas phase as water vapor or steam. These salt ions hold the water molecules in place, making it more difficult for them to move freely. Consequently, the non-salt bodied molecules receive more of the energy provided by the heat transfer through the stove, causing them to get hotter and boil faster. Moving on to the topic of freezing point. The freezing point is the temperature at which a liquid turns into a solid, such as water freezing into ice. It is the point where the molecules lose enough energy to form a solid structure, resulting in a phase transition from a liquid to a solid state. Let us now join Mr. Santos for another science experiment.
Freezing point. So, ang gagawin natin is ilalagay tayo ng asin sa isang container and ilalagay natin sila parehas sa freezer and pagka-compare natin kung anong pinagkaiba nila ang dalawa. So, ayan. And stir natin para ma-dissolve.
Sometime later.
So, ang naging result po natin is yung merong salt po. Hindi pa siya ganun ka yellow. basa-basa pa po siya. Tapos, ito pong walang asin, nag-yelo na siya. Ayun.
Thank you, Mr. Santos. Now to explain what happened. At freezing temperatures, the vapor pressure of the pure solvent equals the vapor pressure of the solution. But the presence of the solute reduces the vapor pressure of the solution. This results in a lower freezing point, as the solute solvent exhibits a decreased vapor pressure, leading to a freezing point depression. This phenomenon occurs because the presence of the solute particles disrupt the orderly arrangement of solvent molecules, making it more difficult for the solvent to freeze. As we wrap up, let's connect the discussion to our current topic. Colligative properties are physical properties of solutions that depend solely on the number of solute particles present in the solution, regardless of their nature. Colligative properties are essential in understanding the behavior of solutions because they are affected by the concentration of solute particles rather than the identity of the solute itself. In conclusion, exploring the world of colligative properties help us learn the fundamental properties of solutions. By delving into concepts like molalities and molarities, we deepen our understanding of how the concentration of solute particles impacts solution behavior. Thank you for listening and have a blessed day.